This is CptWoozle working on Centipede today, continuing where that left off. Let's see what we have. For those who don't know, I usually like to give a quick recap. So, as a fun project, I decided to work on a Centipede game for fun, just to kind of play around with the P5 JavaScript library and see how that's going to behave, and see what it's like, and then maybe make a couple other games. I think the next one I try to make is going to be like a side scroller. I really enjoyed some side scrollers when I was younger. So this is what we have so far. This is what it looks like. It moves across, bounces off the mushrooms, which are the red dots or the red squares for right now, and then I have it so that the mushrooms disappear slowly, just like the original Centipede, and then I have it so that it breaks across into multiple centipedes when hit, and there are a couple of other things I need to kind of fix and play around with there. Now, the collisions with the mushrooms work. The bullets work. The centipede breaking into pieces work. What doesn't work is the centipede colliding with another centipede, and what doesn't work is the centipede colliding with the ship. But I think we've made pretty good progress so far. I might try to spend a little bit more time kind of playing around with that, but that's what we have so far. Also, I'm probably going to eat a little bit of food and take a drink while working this evening. I haven't had a chance to really dive into any food yet today, so we'll see how that goes. But that's what I've done so far. And so tonight, I'll probably introduce the spider. So in the original Centipede, let's pull that up. Centipede in browser. In the original Centipede, we've been looking at. Let's look at this. Let's play it. Block. Bunch of commercials. Yeah, this is the only downside. There's always like a bunch of commercials. So, let's see. But once they finish the commercial, I'll show you. But in the original Centipede, there's a little additional spider that appears, and we'll create it similar to Centipede, where it can create multiple. But I might also clean that code up as well in the Centipede that I have. I don't think the handling of the Centipede is nearly as good as it could be, but as you can see, there's this little green spider that kind of moves up and down. Let's see, 1, 2, 3, 4. Yeah, so I have a similar count over there. Let's take a look at how the behavior works. So shoot it in the middle. I see. So not only does it need to, when I shoot it, I see. Let's try that again. It automatically, wait, now hold on a second. Oh, wow, there are a couple things that I noticed just now. When you shoot a centipede and break it up, it creates a new mushroom at that spot, and it has the mushroom go, or the centipede move down a level. So let's go ahead and implement something similar to that. And then I'll also add in the spider. So let's say when it gets hit by when it gets hit by a bullet, we need to move down one, and we also need to move down one, and we also need to change direction and move down one. So, and we only want to have have one move down. So when we split it off into two, we'll have one move down and one move the other direction. So let's kind of take a look at that. Let's close our browser for now. And we have the mushroom collision that's already been handled, the bullet collision, and now I think we can just consistently have one move down. I guess I could do a random, so it's always going to break it off into another centipede. So the start pieces, we should probably take the piece and have it move down one. So horizontally, and it moves vertically. This dot move vertically, which is 10. So we want it to move down. So when it gets hit by a bullet, the centipede needs to break up, which we already have it doing, and it needs to move down one. And we'll have it randomly pick one to move down here. Also, I think my microphone's a little too loud. Let's lower you by a hair, a little bit. There we go. So when we collide with a bullet, we want to handle bullet collision. We want to go through, loop through the pieces. Here's our handling of the bullet collision right here. And we want to have it randomly move down. And I think the best place to do that is right here, because then our start position is just a level lower. And when it also, we'll put the notes in here. So slice the pieces. Randomly pick one of the two centipedes to down a position, and we want to create a mushroom when it's hit, which is really weird behavior. Like I didn't realize that was happening with the centipede game. So there's all types of little things that I've started to notice is with this game that, like, I don't think you pay attention to nearly as much when you're just like, oh, I'm playing the game, and you're just firing away. So Adobe Flash Player, who uses Adobe Flash anymore? Let's see. Nope, I'm just gonna have to deal with this 30-second ad, but I'll show it again. Adobe Acrobat's really pushing these ads these days. This is like the second one. But yeah, so let's give that a try. Only another 13 seconds. A little bit more, and a little bit more. Anyway, so like I was saying, I noticed that when you destroy the centipede, or it splits in half, see, it created an additional mushroom right there, and it moved down. So the question is should I have it? I think the easier approach is going to be to have it move down and create the mushroom, rather than play the game of having it try to create the mushroom and then bounce off of that. So let's go ahead and go in that direction. So let's randomly pick a direction. Const. We'll call it the random centipede. And we've done random over here before. Let's see. Let's look at all of our random code. Random. What? I don't think I have any. Do I not have any random here? Random. Oh, I don't. Let's look through all of our code. Let's try and find random. Yeah, here it is. That's how we determine our boundaries. So we'll pick a random one, and it's going to be math.random. And we'll do, let's do, I guess one of them. We'll call it head and tail. And more than likely, I'm going to move these over into being constants. So yeah, why don't I just do that now? Where's my types? Yeah, here's my types. So we have our ship ID, directions, object types. We don't actually need this. Export. Yeah, export Centipede types was what we'll call them. And they're going to be equal to another object dot freeze, and there's just going to be two. It's going to be a head or a tail. Head and tail. Export const centipede types, and then we'll come back over here to, let's see, centipede, and it will be centipede.types.head and or centipede types.tail. And there might be an easier and more efficient way of doing it. Actually, I wouldn't say more efficient. I'd say cleaner way of doing it. So we decide what direction we're going to go, and we're going to move one of these down. So switch. Yeah, we'll switch. No, we'll call you const centipede start position, and it's just going to be equal to this dot pieces dot I. Centipede start piece. Yep, it's going to be this, and const centipede start piece. Actually, we'll do this. Centipede start piece dot, and since it's equal to a single piece, it's going to have a vertical move, and it's going to have a vector. So we'll do the following. So we'll say dot vector dot x is now going to be equal to if random centipede is equal to centipede.types.head, then we're going to take the vector and move it down 10 pixels. Yep, minus 10. And we should probably actually hard code you as well. Let's move you as the vertical move for the centipede into the config. I don't think it'll ever be changed, but, and I don't think we have it anywhere else. No, we'll call you here export const vertical, export const centipede vertical move is going to be equal to 10. And now that we've grabbed you, we'll come back over here and we'll hard code you. Well, not hard code, but use the variable. That way it'll stay consistent. And now we can use it down here. Yay! If it's equal to head, then you. We should actually use the move down. And then it'll be cleaner. Dot collide with mushroom. Dot collide with top. Yeah, move vertically. Yeah, we'll have it move vertically. So dot move vertically, and we can probably just do, there's no need to change it at all. We could just say, well, I guess, yeah, we could do this random, and if it's equal to head, we'll put it all on one line, move vertically, and then we'll do the same thing here. We'll have you move vertically, and we'll say that. So it's going to be the same bit of code. And again, I should probably put this and separate off into smaller chunks of code. So, and I think I'll save that as kind of like a whole week refactor session where I kind of refactor a bunch of stuff rather than keeping it the exact same way. So centipede.types tail, and we move vertically, and we'll call you start piece, so that way you'll stay the same. Let's see how that behaves, or if we broke anything. Let's take a look. Open in browser Firefox. So let's get rid of some of these mushrooms. Oh, I didn't get a chance to see that. Well, that was weird. Let's see if we can fire. There's a mushroom in the way, man. Fire. Nope. Nice. Well, kind of. It's still. It moved it down, but not quite. I really have to hit that collision for another. So let's hit right. Well, that keeps terrible. I keep hitting it like right in the head, and there we go. So now it pushes it down one, and so the next thing we have to do is actually have it create a mushroom when on that specific spot. Now that's going to be tough because the mushrooms are aligned to a grid, not just like a random X or Y when the centipede hits it. So I guess I need to pass in some boundaries. Now this is going to be a tough one because the mushrooms are normally created by just having it be like, go make the mushroom, and we create the grid, find the limits, create the margins with that grid so that it's only between these specific spaces, then randomly pick various spots in that grid, make sure there aren't duplicates, and then create the mushrooms. So knowing that, I need to, and I can only create one mushroom, I'm not creating multiple. So I need to get this piece. I need to get this piece's const old piece is equal to this dot pieces dot splice. We remove it, and now we have to create a mushroom when hit. This is called Centipede. It should probably be called Centipedes, but so how do I want to do that? So so we're gonna have the old piece, and we need to create. What do we need to create? We need to get the X and the Y back, but we're not actually returning. Oh, we do. We return the bullet ID, and so this is where some of the things like a use state would come in handy. But maybe we can kind of fake it by, let's see, an export let that maybe we can kind of fake it. Let's see. Let's do a search real quick for JS using a module to imitate state. Placing imitate, or we could use local storage to imitate a store. JS. Well, I don't see anything. Ooh. Oh, wait, nope. I'm not using Node. But I think I can create a default listener. JS. Let's create a custom listener. I think that'll be the better approach. So that I can create a custom listener event. Yeah, let's do that. We'll create a custom listener event that when, and that actually might be the better solution. I think that might be the better solution for our mushrooms as well, so that every time we will, hold on, I don't know if that's the best solution every time. I think it's a combination of things. I think we're going to use a mix. So let's create an event listener, a custom event listener that will listen to create a new mushroom. And when it does that, it'll create a new mushroom at a certain position. So in our game, what do we want to call it? A mushroom? We have the mushroom helper. Let's keep it clean, and even though it'll be a smaller file, let's call it the mushroom events.js. And inside here we'll create const new mushroom. Nope. New mushroom event equals new event. And I guess, how do we want to do that? How do we want to do that? New event, custom data. New event create. And what we're going to pass in here is a new mushroom. We'll call it the mushroom details. Yeah, mushroom details. We'll create you. And I don't have you defined just yet. And then build and dispatch event. Let's see. So I'm just looking over the documentation here. I don't create a lot of custom events. Event bubbling. Awesome. New custom event. So define the event name. Define that the event name is build. No, the old-fashioned way. So we create a new event build. Add event listener. For a child element. An ancestor, catch it? I don't know if that's quite. Ooh, somebody has a complete guide. Let's take a look. Create new event. And okay. There's the new custom event. Dispatching custom events in JavaScript. My event, dispatch event. Cool, but where's the custom code to actually do the event? So add event listener. Yeah. Hold on. Let's look at somebody else's example. New event. Okay, cool. We add the event listener. Add event listener, custom event. I see. So I see. So right here, we'll add an event listener called my custom event. Add an event listener. Create. Yeah, new event. Create mushroom. Let's call it create mushroom so that it matches. So it will be create mushroom event. And a new event create mushroom. We could do create dash, but we'll just keep you create mushroom. So there's our event where we console log e. How do we pass in custom data again? Let's take a look. is trusted, blah, blah, blah. New event, and then bubbles? Sure. Bubble event. E.prevent default. Where's the... There it is. Passing custom data elements. E.detail. So I guess would be E.mushroom. So yeah, we'll just spit out everything for now. And then let's look at... We need to add an event listener. Document.add event listener. What are we adding it to? I guess the whole document. And then when we want to, we'll document.dispatch event. Create mushroom. So let's see how that works. Let's come over here to 1. We need to come over here to the centipede and have it so that when create a mushroom when hit. So we'll document.bubbleUp, and the name of the event is going to be create mushroom. So we'll come back over here to Centipede, and it's going to be called create mushroom. And when the game starts, we need to make sure it runs. So import. I don't know if there's anything to import. Let's see. How do you add? Let's see. JavaScript. Add custom event in module. Yeah. Creating with E6 modules. Function event.js da 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 da. So trackable call event emissions da da da. So I know how to add the custom event listener. Custom event in module. Let's see. I see the custom event constructor. Let's see if this has anything on it. I guess when we do this setup, we would add the module in there. DOM events. Create event. Event.prototype.register callback. Not relying on DOM events. Okay. So function event.prototype. Add event listener. New reactor. Oh, we would need to register the event here. Register event Big Bang. Add event listener to Big Bang function. So we would need to prototype event.register callback. I may have to try that. You might like this approach. You'll get all the features you know from the usual DOM events. You just create a DOM event, document.create text node, event listener of equals new event target. Oh, I see. Bind target. Then we add an event. Simply create a new event target instance, like you have suggested. New event target, add and dispatch it. I don't know if, I mean, I could, and then just have the mushroom handler handle it. I think that may be what I do in game, and I don't want to do it all the time. So we create the grid. Let's create a new function in here called, well, let's go over here. Const. Do we create a new class where we do all of this? Or do we move you? Let's see if it works first. So let's come here. Let's create a new event. And then we console.log e. Let's do that first. Let's see what that looks like. And then this is kind of unnecessary, but it just kind of sits there. But let's see if it works in the browser first, and then we can kind of rearrange it. And again, there's going to be a refactoring session at one point where I kind of refactor all of this. Nope. Nope. It's broken. It's broken. Mushroom details is not defined. Details of the mushroom. Mushroom details. And details is not defined. Where is custom event modules? Let's take a look. Create custom detail colon hello world. Detail hello world. Details and oh, it's detail. Let's create a mushroom, and it's gonna consist of I don't know what it's gonna create. Naming conventions, custom event, double click. Let's see, custom event with data. Yeah. Custom event constructor, new custom event. Do we have to pass in the details now? Cat found. Oh, I see. So we create the custom event first, and then we have to tell it the details. We don't know the details yet. We don't know the details yet. With data unknown value. Let's see. I know, not unknown. We'll call it dynamic. Dynamic data. Passing in and having them triggered correctly. So you're invoking and passing it to the return value. No, not quite what I want. Find two created elements. One click, double click. Let's see. We want to add an event listener. Custom event. So we don't know what that is. So we create the event, and then we'd have to create a whole listening system. When it comes to, we want an event emitter. And data, event emitter, and subscribe. Oh, there's a custom event emitter. I thank you, good sir, for whoever created this. And then we would event emitter data and then subscribe. So let's make a new file. Let's make the event emitter. Let's try it. Thank you to whoever made this. This is neat. Are we doing module.exports in our modules? No, we were doing export default. So we come over here, export default, the event emitter. So we have our event emitter here. Pretty cool. Show, is it not export const? Export. Yeah, no, export const. Oh, I guess we can't. Let's go back to what we were doing. So module.exports. And then we need to, will this even work? Yeah, I guess it will. And then we import it. And then, oh, we need to add subscribe. So we take you, we come over here to mushroom, we import you, we take our event emitter. Wait, no, this is the wrong spot. We need to put you in mushroom helper. So we import you. Then we come over here and we create a listener. Every time we, where would we put this? I think we should put it on game. Yeah, we're gonna have to put it on game. So at the top, we'll import you, and we just need to create a listener on game that change setup. I guess we would just need to do one. No, we should do it on the draw level. Let me make sure. Yeah, we want to do that on the draw level so that it just, well, but it's constantly doing it. No, I get it. We would put it inside the setup. So it would listen once for the change event. And when it does, it will adjust our mushroom handler and push in another value, console.log event. So we'll see if this works. And then in our this, we'll add in this event emitter, and we'll put it inside of our code. So we have our mushroom, we have our bullet helper, centipede. Yeah, here we go. So in our centipede, we'll import our event emitter. This isn't where it's from. Dot/event emitter.js. And then we'll come down here and we will do event emitter.dispatch. So when it's hit inside Centipede, we need to handle mushroom collision. I missed it right here. Create a mushroom when hit. We'll do event emitter.dispatch create mushroom, and we could create a bunch of these, and I might use them for a few things because this might be the better way to handle the hit rather than passing back information in a really unclean way. We can create a simple event emitter. And the data we want to pass back is hello for right now. That's what we'll do. Let's come back over here to our game. And you're just going to be event emitter.js. Yeah, /event emitter.js. Cool. What? No. And let's see if that works. And you don't. Oh, fiddlesticks. Ambiguous export event emitter. Is it ambiguous? I don't think it is. Event emitter, there's only one const. Let's take a look at the code here. Let's go back here. Yeah. Events emitter module.exports. I think we do something differently. I think we do export.default. Bullet helper. Is dispatch a thing? Yeah. It is. So export default event. Hold on a second. I just don't do enough modules. Yes. Create module function. Yeah. Modules. There we go. Yeah. Export const export function. So it would just be export. So export const event emitter. Yeah. There it is. And then we can come back over here to game, and we can pull in event emitter. And there it is. Let's do an inspect so we have it here. Cool. So here's our inspect window. And let's go ahead and create 0 mushrooms for now so that we can kind of test this out without interfering. Fire. Did that work? No, it did not. I got nothing. Event emitter dot subscribe to the change. Is this even supposed to work? Emit.js. You're here. And then here. And so you're here in the game. Event emitter dot subscribe. I don't know if this will work. I think this might require Node. I think it might. Let's do JavaScript. Let's do vanilla JavaScript. Custom event dispatch. Let's see if we have to create our own dispatch system. Let's see. There's my custom event. Yeah, no. Let's see. We can create an event object like this. Yeah, I see ya. Then we have our event. But dynamic custom events. Event.dispatch. Well, it looks like we can do this. So element.add event listener. And then we can do dispatch new custom event. Oh, yeah. So we can do this. Let's try this. Well, that was a waste of time, but oh well. Try a bunch of stuff and fail and delete anyway. In our game, let's add you here. Let's do a document.add event listener, and then event listener is going to be called create mushroom. Let's keep it consistent. New event alert. No, we want a console.log the event. Then we come back up here. There's no more event emitter, so we'll get rid of you. Come over here to our Centipede. We still need to modify you. There is no event emitter though. And if I look back here at this example, all we have to do is document.dispatch. So let's come back over here to Centipede and let's take a look. We want to, yeah, here it is. Document.dispatch event. And the name of my event, let's close some of these windows because we don't need them all. The name of my event is going to be create mushroom. Come back over here to Centipede, create mushroom, and we'll leave this in here as details, John. Let's take a look at what that looks like. So Let's inspect. Oh, it looks like it's caused a crash already. So let's inspect. Let's fire away. Ooh. So let's take a look at the crash. Event emitter is not defined in the current scope. If you would find it in your code, you should check its scope. Event emitter is not defined. Let's take a look at what I have done. Event emitter. Where are you? Event emitter. Oh, I left my old code in there. Look at me being an idiot. All right, let's try this again. Fire. Fire. Cool. And let's see if we outputted anything. Hey, there's my details. Details. So yeah. So what we'll do is we'll use this custom event handler. We'll close you down for now. We'll use this custom event handler to dispatch the creation of a mushroom. And the details of that mushroom are going to be, and we'll actually use this event a few times. So in the game, we will event, and it's actually going to be called the mushroom details. We'll call it new mushroom details. And what you're going to do is mushroom handler, you're going to handle it. Mushroom handler dot create new mushroom based upon the new mushroom details. So there's several things we need to do. One, we need to create a mushroom. It creates a single mushroom. So yeah, create single mushroom. And these are the new mushroom details. And what we do is we have our grid. And we say generate single, handle the button collision. So generate single mushroom. Yeah. So we get the grid. We get all the existing mushrooms. Where do we get these mushroom keys from? Oh, I see. We should probably store them somewhere so that we know what's available and what's not. Let's ponder this. Let's take a quick break. I want to nab some food. Have a drink. We should store the mushroom keys somewhere. So we know exactly where it is. So we get the mushroom key. I'm not going. Yep, we get the mushroom key. So when we create one, it can't be random, and we don't actually care about the mushroom key. What we do want to do is get information. So the grid? We've been using this. Oh, we generate it. We generate the grid from over here. We pass in the grid. And find the X and the Y. Yeah. Let's see. Let's go. Go to. We have that. Get the grid keys. We have that. We have the creation of the grid too. So we need to know if a particular mushroom fits inside a certain. How do we want to do that? We have the grid. So we want to find whether plus or minus 10. Yes, we need to know the x and the y, and then fit it 8, 5. Fit it to the find the closest one. Oh man, that's going to be a pain in the butt, isn't it? Let's see. So we have the x and the a and the b, and we create the mushrooms at those. So, given a grid. Yeah, let's do the closest. Hold on. I think P5 has. Let's go. I think P5 closest. P5JS. I think P5 has a closest. So given an array. Ooh. Find the closest close in shape. P5 distance. Yeah. So we need to loop through and find the closest one. Let's take a look. Let's actually see if someone's done it. P5JS. Find closest. Yeah, find closest point. Yeah. Draw. And I imagine we'll have to use a loop. Yeah, so it does this. So create vector, draw ellipse text. I see. So we need to know, given a vector, we need to know the distance, text, orthogonal projection, find the nearest point along the segment, and it's consistently doing this again and again and again. Nearby target. Let's create vector. Yeah, so I guess what I would need to do is, let's see. Calculate this 5 points. Yeah. So you can use the max function. Returns the largest value in a sequence of numbers. So I would have to loop through, based upon that, where it was destroyed, loop through the grid, find the closest point, and create a mushroom there. And so let's see. Yep. Text im max returns a large in a sequence of numbers. So I would need to. Yep. All right. Create grid, mushroom helper. We have the grid. So when we create a single mushroom, we need to loop through the grid or the closest position. Once that position is found, and how do we do that? We We need more than just that. We need more than just that. Because we need to know it has to be a very specific point. Move through the grid for the closest position. Once that position is found, create a mushroom there. So create single mushroom, new mushroom details. Cool. Let's see how fast it can do that. Get a new mushroom there. Once the position is found, we have to make sure a mushroom is not there already, and then create the mushroom there. So now we have the mushroom details. Let's go ahead over to the centipede piece, and we need to dispatch the mushroom details. So we have the old piece, detail, and we just want to pass in the old piece. We will call it mushroom position. Mushroom. Yep. Yeah, we'll call it the mushroom position. I'll call it the mushroom details. So we have the old centipede piece that we pass around. Then we're going to take that piece, and we're going to loop through the grid and find the lowest position. And now I'm not as good as this as I should be. So JavaScript for loop smallest. And you can do this with the for loop. Yeah, find the smallest without min math. Min math? But yeah, sure. So this is what we want. So yeah, that might be the easiest. So what we would do is get the distance for every single item in the grid. We have to do this every time though. Let's see if there's an easier way. P5. Find P5JS given array of points. Find the closest. No. Nope. Find the closest points in an array. Yeah. If I have a function like that, yeah, there are closest pair of points. One intuitive, but perhaps is to simply brute force the items in the collection. That is for 2 points. Use for loops, 3 points. But let's see. Let's see. There's an algorithm for this. Oh man, this is where algorithms comes into play. So class point, we have the x and the y. In compare, need to sort. Let's look at the JavaScript. Yeah, so we have our point. Compare, distance, strip closest between a strip of given size. We don't know the closest util. Every function to find the smallest distance. There are 2 points. I see. So closest util contains all the points sort of according to x coordinate. We already have that. I don't know. This is where algorithms come into play. I'm not as good at them than I should be. Point coordinates and transfers. Let's see. calculate this between 2 points. Let's see. We have multiple points, and I guess the brute force way is kind of inefficient. So yeah, I guess we need to do that. So let me see. We'll start off with looping through all the elements in the grid. Yeah, let's do that. Start grid. Yeah, we'll just loop through all the elements in the grid and find the distance between them. So, yep. So we'll do a for loop for, yep. We'll just loop through the grid. The grid for the closest position, key and value. Nope, it would be a let. Let smallest equal an empty an object. And so we'll say that right now we'll start off with smallest being equal to this dot grid position, this dot grid position 0. Or do I give them all a unique ID? Did I give them all a unique ID? This dot grid, canvas size, grid key. Yep, nope, I just gave them the smallest, so it would be 1. There is no 0. We loop through all of them. Find the smallest. So const distance is going to be equal to. We need to get the. So const. Call it the. We'll call it potential mushroom x is going to be equal to the new mushroom details because it's a single piece from Centipede. Who does this stuff on the fly? Why am I making this? Because I'm crazy, that's why. So this mushroom dot vector, it's a single piece, vector dot x. And we'll call this the potential mushroom y. It's going to be, nope, details dot vector dot y. So we have those. And now we can use the p5 distance function. Const. Nope. It's going to be the p5js distance. Yeah, we'll use this to get the difference between 2 points. And whichever one is the smallest is the one that we'll use. So, let's look. Yeah, distance of x, y. So these are the 2 points. It's going to be distance of this dot grid. Grid p. It's going to have an x and a y. So we could just say const grid piece grid cell is going to be equal to this dot grid at this key. But we have the value. I don't know what I'm doing. We have the value. So we could just say value dot x, value dot y, and I think I did something similar over here where I was an idiot. Yeah, yes it did. So we have value dot x, value dot y, and you're going to be potential x and potential y. And smallest let smallest, equals this dot good dot. But we don't actually know what the distance is. So let let smallest distance equal, what is it, 4? Let's do the canvas size. Canvas size. Yep. And let's look at the math on that. Find the smallest value. No, dot sort. Yeah, I guess we could. But do we want to? Do we really need to? Because we'll be looping through it twice. So if, yeah. If the, where was I looking? Yeah. If the distance, screen. Yeah. If, nope, we can't do that. So we'll put you just over here. So smallest distance, if the distance is less than smallest distance, then smallest distance is equal to distance. And we'll do this. And smallest is going to be equal to this dot grid x. No, this dot grid dot e. And once we go through, once the position is found, make sure there's not a mushroom there. So how do we do that? I have all the mushrooms. What's x? X is the count. I should keep track of the keys now that I look at this. Mushroom, mushroom, mushroom. Mushroom ID. This dot key is equal to key x. This is the ID. And the key, I don't know what I'm doing with ID. I really could just swap it out with the key. I probably should. I don't really know why I need both, but let's keep it for now, and then I can always clean this up later. Collision, generate single mushroom, new mushroom. Why is saving the index of the for loop? I have no idea. But we'll keep the key since we have it. Let's return both. Let's return the entire grid piece. What's that? And the key? I don't know what the key is equal to. X, Y, getting an object key, getting the current object key. Well, no, that's the actual thing. So we actually need to get the key. So we look through the grid keys. Wow, how do we want to handle that? Let's throw the key in here too. Uh, call it the grid key. Grid key. And that way we'll have it when we come back over here. Mushroom positions dot grid key. That way we'll have it as well. And so once that position is found, which we have the smallest. Make sure there's not a mushroom there. So let's make sure mushroom there. If well, it how do we do this? If mushroom, we'll find mush this dot mushrooms dot find and the single look through the single mushroom. It's existing mushroom. And here's an example of where you would probably break this up into smaller functions. So I'm doing two things here. So I'm creating a single mushroom. So we should probably break this up into smaller functions. So let's do find closest cell. And it's going to pass in the mushroom details. New mushroom details. And what you're going to do is return for me just so we'll loop through you, we'll grab it all and find closest cell and the smallest. So we can now take all of you and say const smallest is going to be equal to this dot find closest cell with the new mushroom details. So we'll clean this up here. And then we'll do this const. We'll do a mushroom is existing. We do the find existing mushroom. That's a simple find. Get existing mushroom. We'll put you into a smaller function. And potential mushroom position. We'll call you the potential mushroom. Potential mushroom. It's just going to return this dot mushrooms dot find the single mushrooms. We'll look for a single mushroom where the single mushroom, and what is a single mushroom? Dot x single mushroom dot x and single mushroom dot y is equal to potential mushroom dot y. Existing mushroom equals this dot get existing mushroom, and it's the smallest. Smallest. We'll actually call you the closest mushroom. Closest empty cell. I'll just call you the closest cell because it may not be empty. So you're the closest cell. Get existing mushroom based upon the closest cell. And if no existing mushroom, you want to create a single mushroom? Create. Try create. I guess we want to call you potentially create. Maybe create. I don't know what we want to call you. If there's no existing mushroom, we need to add one. So we can literally just do what we do here. Mushrooms dot push. Yeah, if there's no existing mushroom, it's a one-liner here. Do we need to? Yeah, well, this function does that. So it would be this dot mushrooms dot push. We create a new mushroom. Get max mushroom ID and nothing. It accepts, and it's simply going to return this dot mushrooms. Let's do JS find. Let's do. Want to do JS find. We could sort, but I don't want to. JS find max value in array of objects. Max value for property in an array of index. It's better to use reduce with a large array, so let's go with that. Returns the object. I just want the actual max. Max. Da 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 da. 30 time characters complexity O of n. O of n. So max A. No, I want to know, yeah, the max value, but let's look. So let's do, no. Yeah, we could do this. Grab all of them and then do max. This will terminate with the highest amount. Object to the amount. So the assumption assumes that there is no amount lower than double position float can go. This one breaks upon all negative values. Updated. Yeah, let's play around with this. So the max current amount negative infinity. So highest returns 1 amount. No, I just want the single max. Like, no. Returns a shot amount instead of shot. Yeah. Yep, this is what we want. Yeah, this is what we want. Let's go back over here to our code. So we want to return this. Let's move you over here so you're bigger. Well, just more space. Let's close you. We want this dot mushrooms dot reduce. You can't spot reduce. Max single mushroom. Yeah, single mushroom. And we want single mushroom dot ID. Yeah, that's what we want. Single mushroom ID greater than max. Otherwise, single mushroom dot ID colon max comma 0. Hold on a second. I think I'm wrong here. Yeah. There we go. So create a mushroom there. Const max ID is going to be this dot get max ID. We want to add one to it. Is equal to max ID plus 1. And then this is the existing mushroom's closest cell. We need, there's no existence, so we'll get the closest cell dot x potential mushroom, yeah, dot x dot y. So you would be closest cell. Boy, Bay, like these are getting more and more complex as we dive into more and more of these pieces. So here's this. I may not be able to get around to create single mushroom on the event listener. Let's check into our JavaScript and see. Let's check into our program and see what it looks like. Open in browser, Firefox. I clearly messed up something. Let's inspect you. Config was blocked. I forgot something. Let's come back over here. Come up here. Config.js. Awesome. So fire. Nope. I messed up something. I say we. Mushroom.vector is undefined. Let's go to our mushroom helper. I know what I messed up. I messed up because I don't have any mushroom events. That's 1. 2. Let's go to mushroom. Let's go to game. Create single mushroom, new mushroom details. Before we get here, let's put a debugger statement in here and see what happens. Bounce, fire, hit. There's my debugger up there. Let's move everything down so we can see. So we want mushroom detail. What? What? That's. Wait. What? Type is create mushroom sources and element. Wait. Where's our mushroom details? Oh boy. Helpers. Centipede. Where are you, Centipede? Where are you? Okay. So I clearly forgot something. There's the old piece. I see. I think splice. Let's take a look. I think I messed up on splice. So splice.js, not the movie. All right. Splice. Changes the content of array by removing existing into place. Start, delete. Description. Const fish is equal to removed is equal to yeah. So old piece should be equal to the piece that was removed. So let's put a breakpoint in here. Let's fire. Hit. Oh, I need to actually get the old piece, so it's not just that. So you're going to be old piece 0. Yeah. Old piece 0. So let's try that again. Fire, hit. So the new mushroom detail is none. So we need to come back over here. You're called mushroom details. I ain't got nothing. So mushroom details. Come back over to the game. Mushroom details. Mushroom details? Mushroom details? Let's see. Mushroom details. Oh, I need to put it in detail. No wonder. Let's see. Where is my event creation stuff? Custom event. Find the custom event. Event.detail. So then detail colon. So I need to come over here and say detail colon the old piece. Then back here. Hit. New mushroom. There's my detail. So that's going to be old piece 0. Then we come over here to our mushroom helper. Find the closest cell. vector x, vector y. Let's see if this works. Did we take out all our debuggers? Let's see if we did. We did. So there'll be no breakpoints. Let's have it bounce off the wall again. Fire. Almost. Let's see if I did something wrong. I did. It looks like vector is undefined from mushroom details. You should be a single piece. So let's put a breakpoint here. Debugger. Go. Let's try again. Fire. Hit. Move all down. Mushroom details. Oh, I see. Detail. Dot. What do we call you? Detail is an object. And this detail. So we need to come back over here and say mushroom details dot detail. Let's do event dot detail. And then fire, hit, object. It does have a vector. Cool. So that's the problem. Event detail. Back over here, our mushroom helper. Take away the debugger. And I think we're almost there. So we bounce, we hit. Almost. Something still isn't right. Let's see. So can't lexical declaration dist before initialization? Can't what? Can't dist before initialization? Let's copy that and can't access lexical dist before initialization. I think it's because I have it before we finish doing our draw phase, and I think that's going to be the problem here. So let's do a quick search. Was initialized E5. Let's look at P5.js. Yeah, I think it's because we can't declare it. Let's do this. JS distance between 2 points. Distance between 2 points. X and Y. We apply to distance 2 points. Wait, what? I just want to know the distance between 2 points. The distance in any number of directions given an X and a Y. Euclidean distance. Nope. Nope. Measuring the distance between 2 points. Let's see. I should know this stuff. Yeah, I should know this stuff. Let's create a helper function that'll handle this. But we really shouldn't be using it that much. Static get distance. I don't know why we're not using consts, but probably because it was written before that. Const. And I misspelled it. So we do const equals that. So we'll use get distance here in our mushroom helper because we can't do distance. So we could say const helpers. Yeah, I just made it. Helpers. Helpers dot get distance. And like the question really is could I move this? I don't want it to constantly keep creating event listeners, and that's the reason why I'm not putting it inside the draw, because I don't want a no loop. But I don't want to put it inside the draw function. Otherwise, import. There it is. I don't want to keep putting it inside the draw function because it just loops again and again and again. What? Helpers. No, I need to import helpers. Show context actions, import helpers. Yeah. I could just do a single function though. I might think about cleaning up some of those. So let's fire you again and see if you're hit. Oh, well, we've maybe gotten a little bit further. Closest cell is undefined. So we're back here again. Closest cell? Closest cell. Yeah, you're right here. Closest cell. What? Line 24. Let's look at where that is. So I can't see. Closest cell? What do you mean it's undefined? Let's put a debugger here. Find closest cell. Get distance between the potential value of x and y. What? 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 Let's see what's going on here. Bounce, fire, hit. Why are you undefined? Yeah, it looks like I messed up something. This dot find closest cell. Debugger here. So let's hit U. This dot grid. This dot grid 1. Yeah, you what? Why can't you get I know why. That's why. This dot grid key. Object entries. Let's see if that works better. Do I still leave my debugger up here? I did. So let's try that again. Hit. Bounce. Closest cell. You're still undefined. What is wrong with you? Let's try again. Refresh. Hit. What is... something is wrong here. But we know that the grid is here. I guess I could say dot 1. Does it not exist yet? Hold on a second. New grid. It's weird. Hit. Am I putting it in the wrong spot? Hold on, let me see. Nope. I passed in grid, so you should already exist. Set up as a new grid. Something is wrong and I'm missing it. I'm trying to figure out what's going on here. Because mentally, I think I'm hitting all the right spots. Yeah, this dot grid, position 1. Get object property by name. Yeah, there's two ways. You could either do the dot, um, or I thought, yeah, you should be able to do um, JS object key number. Yes. Oh, it'll always get converted to a string. Oh, oh, I see. Map is the better approach for this. So, I guess map is going to be what I use. Add key value. Yeah. Yeah, let's use the map. So, looks like we're switching over to a map for this. It's going to be the better approach. Let's come back over here to our new grid. So we have a grid. Let's come over here to our grid function. So this dot grid is going to be equal to a new map. And then we will say this dot grid dot set parentheses. This is the key. And this is the object. And then we increase that. This dot grid key. Limit the keys to a specific area. Allowed keys. How do we loop through a map? And I don't iterate through them very often. So let const key value of the start grid. I guess I can just loop through this. I don't have to do object entries. Or of cool. And get this position for. So it would be this dot grid dot get key. Nice. We use the map. I don't use them too often. So there's our map. And then in our mushroom helper, we pass that in. Let's find all the references of this dot grid. The smallest is going to be this dot grid dot get. Wait, this dot grid dot get 1. And of this dot grid. And then the smallest is going to be this dot grid dot get key. Let's see, are there any other references? It's actually just simpler to do this dot get. Yep, get grid keys. Yeah. Yep, that'll work. And let's see if this still works. Bounce, hit. And no, it doesn't. So this dot grid dot get position. Oh, hit. Still not right. Oh boy. Mushroom smallest. So Q1. Nice. So bounce, hit. This dot grid small. Wait, what? This dot grid is a map. Then we say this dot get position for key. This dot grid, and the key equals 1. This dot grid, let's take a look at you. Entries, at position 0. So the key is equal to 1. And so this dot grid. So wait, what's going on here? This dot grid dot get, the name of the key, get position for key 1. Why are you undefined? Oh, let's see if that works instead. So here, hit. There it is. There it is. Let's see what happens when we hit play. Oops, nope, still not quite right. This dot grid is not iterable. Dot grid. That's the iterable run, but do we actually want all of that? Hold on. So we want to loop through all the allowable keys, not everything. We want to loop through all the allowable keys. Yeah. So we'll do this instead. Const grid keys is going to be this dot grid dot get the grid keys. It's just an array. Then we're going to loop through for each const key of this dot grid key, this dot grid. Oh, of this grid keys. Const grid cell value is going to be equal to this dot grid dot get position for key, and then we can say grid dot x potential. And since we already have it, we can just say that and return smallest. So let's see what that looks like. Hit. Cool, we have our closest cell. We step through, we step over. We didn't find it. We step over. It's max ID. And let's see what that looks like. I think we've created our mushroom at that particular spot. Oh boy, that took longer than it should have. I made so many mistakes. Bounce. Hit. Nice. And then, all right, so then the only thing we have left to do is figure out collisions for, oops, that's not right. To figure out collisions for when we hit, when the two collide. So we've gotten to the point where we're creating mushrooms on hit. That took a lot, but I'm not unhappy with that. We've broken it off into smaller individual functions where we just find the closest cell. We've switched over to a map, which I think will be a bit better than an object for what we want to use it for. We've had to use a slightly different get distance, but that's not terrible. And yeah, so I think I want to look at a couple of things. So I think this puts us exactly where we want to be for right now. I guess I should start on the creation of the spider. Internal new file. Yeah. Spider.js. And I guess we'll do this. We'll need to create an overall centipedes. But yeah, we'll do a new spider. And what we'll do up here eventually is move our spiders to an event handler. So centipedes is our variable, and so we should probably call you, I don't know, mushroom helper is fine because we need a mushroom helper that kind of handles all of that. I think we could fix some of these things and make them a little bit cleaner. But let's work on spider for now. We're going to handle it similar to the centipede, where it's going to exist and kind of bounce, but it's only going to be one thing. So let's create our class of spider. The spider's movements are going to be interesting. So export default class spider. Let's create our constructor. It's going to be empty right now. We're going to have where it's starting at start x, start y. I think it's going to be the same. I think I'm going to have to move these all into some smaller classes at one point, or subclasses of other things. It's going to be speed, then we're going to speed that up. There's no length, and it's not going to have a custom direction because once you kill a spider, it's gone. I imagine it might have hit points. Let's give it a unique ID. And let's give it a slightly larger diameter, start x, and a speed. So we'll just grab you guys from here. And then we'll need to do the same thing. In here, we'll create a run and a draw. And it's going to do this dot move and this dot draw. Now it only moves up and down, so our move function is just going to be bouncing it up and down. This dot move. We create the vector. We create in this one. It's 0. So let's take a quick brief moment and take a look at how it behaves in the existing approach. Centipede in browser. I gotta find one that doesn't make me wait 30 seconds. Free game online. Maybe this one will work. You're gonna make me wait, aren't you? All right, I got 30 seconds. Now I'm gonna get a drink. I hope everyone's having a good evening. It's just been a busy day over here. A busy day. Work and other things. Let's see how it goes. Apparently America runs on Duncan. Oh boy, and it's just freezing, so I don't get any sound, just kind of frozen thing. I guess it's meant to be a joke. Play. Okay. So let's see how it moves in a diagonal and it takes out mushrooms as it goes. Okay. I don't see it. It didn't take out any mushrooms at that point. Let's see. Nope. It hit the mushrooms and didn't do anything with them. Does it go as high as the other ones did? It goes a little bit higher. I see. I thought it... I don't see it destroying any mushrooms. Oh, it does. If it hits it from a certain angle, it destroys them. So if it comes in vertically, do I want to compensate for that? I don't know. So let's look up P5 diagonal movement, but I think that should be pretty easy. P5 diagonal vector. Vector is an arrow. Drawing diagonal lines. How can I normalize diagonal movement in P5? Normalized result is so vector up 1, I guess. We do 1, 1. Oh, yeah. So this speed is equal to this dot speed. So it moves. Let's take a look at that again. Now that I think about it. Oh boy. Because I think it kind of moves randomly, so it moves in, down. I'm going to have to create a whole custom piece for this. I think that's where we'll end the stream today. This move is going to have to be customized, so it's going to have to kind of randomly move diagonally, because it moves diagonally, then sometimes it moves up and down, so it'll move in. We'll let it move in diagonally, randomly. It only moves in one direction. It only moves from either left to right or right to left, so it comes in from the left. So we'll have it if the position is left, and we'll keep those directions. So start speed, this dot. I'm going to do the same thing we did up here, where we have a horizontal and vertical direction. There's nothing custom about this one. It starts off by going to the left first every time it's created, and we'll have it randomly created. We'll call you init, and what you will do is you will determine whether or not we'll come back over here to mushroom helper, because that's where, nope, I'm wrong, it's Centipede. This is where I have my last random function. We, based upon this, will determine this dot horizontal direction. So it'll randomly pick one, and this dot horizontal direction is going to be. That'll determine which side it's going to come in on. It'll start off screen. It'll start off screen, and then it always starts off screen. So the initial start of Y. Oh, that's right. Based upon this dot start, it's not start Y, it's start X, is going to be equal to, based upon the direction, it's either going to start off screen. So this dot horizontal direction is equal to directions left If that's the case, then we're going to start at position 0, yeah, from the left. Otherwise, nope, I'm wrong. There it is. 0 or 0 or canvas size. That way we don't have to do that. And I think I created some configuration pieces for 0. Yeah, canvas start. That way we're not hard-coded in case the canvas gets bigger or we do those lines. So that's where it will start. And every time we start up, we do this dot init. So when we init, we'll start at that position. I'm going to have it be a bit bigger. I'm going to have it be like a 15 size diameter. It'll have its own unique ID because that way we can have multiple. And then the move I'm going to have to work on someday. So it looks like to start, we'll just have it move randomly. So it can start and move up and down. I'll let it do a certain number of movements. So when it starts, you can go up or down any number random of times, then start moving diagonally, and then change that up. Yeah, let's pause on that for right now and come back to that on Sunday. Thank you everyone for tuning in on this Friday broadcast while I continue to write in Centipede or create Centipede. Here's what we have so far. We have our mushroom creation, but I have it turned off at the moment. We have our centipede that moves across the screen. It generates, that's a weird bug right there. I'll have to fix that. So we have a centipede that moves across the screen. As it gets hit, it generates our quote-unquote mushroom and splits off into multiple centipedes, just like the game does. And what we don't have it handling is the collision of other centipedes. That's something to work on. We do have it handling bullets, and we don't have it so that the game processes when there's no more centipede, or when it crashes into the ship. So there are quite a few more things to work on. Thank you again for tuning in, and I hope everyone has a wonderful weekend. Hope they had a good Friday and a good Thanksgiving. And I hope everyone a good day. Take care and